Good morning, calculus students. Are you excited? You should be. This is the last official unit that covers all the material for the AP and just about everything that's on the STC also. Between this and the last session, that is like 2 chapters worth in the STC. So we're actually 2.5. So let's see what we got here left. We are going to talk about the second fundamental theorem today. It's day 61. After that, we're going to do a little more advanced integration. Very important. Now, this topic here is required by STC, but based on what I'm reading about this AP exam, they may not be testing this particular idea. But I will still be covering it. It's actually in 2 different lessons about differential equations. Then the most important part of integration is, why do we integrate besides accumulating areas? And we'll be doing that, and we'll be learning volumes. And there's actually a couple kinds of volumes, so we're almost done. The sooner we get done, the sooner I can leave you alone, and you'll be happy. Let's carry on. Second fundamental theorem of calculus. He's looking at, given the function f of t, small f, and obviously the antiderivative is big F. Given that f of t below, so here's my functions in terms of t, we are integrating from a constant of a 1, could be any constant, it doesn't matter, to a variable expression of f of t dt. And he wants us to find big F of x, and when I get done with big F of x, take the derivative of big F of x. So big F of x is all of this, and then do the derivative. And what you are going to find out, in a nutshell, is that f of t becomes f of x. It really does in the long run when we get done. So let's see what's happening here. First of all, let's start with big F of x will be the integral from 1 to, he put just a plain x, of f of t. F of t is 4t minus t squared, and it's with respect to t, obviously. So when I integrate this, don't be afraid, just do what you know to be true. Integrate this like you would any other time. Add 1 to the power and divide by it. 4t squared, divide by it, minus t cubed, divide by it. All of this from exactly what you see here, a 1 and an x. What's the next trick? Substitute the top number. So substitute the top number in. Well, the top number is an x. So it looks like this. That 4 over 2 becomes 2, so it's 2x squared minus x cubed over 3 minus all of that minus what? Plug in the 1. 2 times 1 squared is 2 minus 1 cubed is 1 over 3 is minus a third. Put it all together and we have, we put them in order of their, I'll just leave it. 2x squared minus x cubed over 3 and 2 minus a third. This is the same thing as saying 6/3 minus 1/3 is 5/3 minus 5/3. So there's my answer. That equals big F of x. Now you couldn't have predicted that. There's no prediction there. My shortcut comes out when I do now f prime. Watch this. F prime of x. So I'm doing the derivative of my answer here. 2x squared becomes 4x. X cubed over 3 becomes 3x squared over 3, which is minus x squared. And the derivative of a constant is 0. So there is my f prime of x. What do you notice? It's identical to the function in terms of t. I used to tell the students this was a way to change variables. And it is, but it's more than that. But it is kind of cool that you could have guessed at what the answer was going to be, at least for problem 1 and problem 2. There's a little trick that I didn't talk about yet, and I will show it to you in just a second. Let's do the next problem. It's kind of cool. Big F of x is equal to the integral from 1 to x of the integral of cosine of t dt. That equals to the integral of cosine is sine of t from 1 to x, which equals to sine of x minus sine of 1. That's not too exciting, but look what happens when I do the derivative of big F of x. The derivative of sine is cosine of x, and the derivative of a constant is 0. Big F prime of x is cosine of x. When I started with cosine of t, that should just be like amazing to you. See, what we're doing is the derivative of an integral, and you're noticing that the derivative of the integral cancels out the integral sign. So that explains why you're coming back to the beginning. But then because I have my limits of a constant with an x up at the top, the t is turning into an x. It's exciting. Okay, now I'm going to do this problem wrong. Don't copy number 3 right now. I want you to see something. I'm going to do it wrong because there's something up in 1 and 2 that I didn't share with you. Kind of like the secret formula. But now he wants me to call big F the integral from 0 to, well, maybe it will still come out. You know what? It'll still come out. Never mind. If I do it the way I did number 1 and 2, you're not seeing a secret. The secret would have been this. Let me just see. My secret would have been f of x, if everything else was true, would be my f of t changes, except for the fact that I would be expecting an x cubed instead, right? That's what I'd be thinking the answer was going to be. It's what happened on 1 and 2. But look, that's not what's going to happen, because there's a big secret here. Big F of x really is the integral from 1 to x squared. And I did mention to you, it doesn't matter what number they have here. It's a constant. When you derive a constant at the end, it goes to 0 anyway. So of t cubed dt, I end up with t to the 4th over 4 from 1 to x squared. Plug in the top, minus plug in the bottom, and let's see what happens. When I plug in x squared, that's x squared to the 4th over 4 minus, plug in the 1 over 4, 1 to the 4 t to the 4th. When I plug in the 1 is t to the 1, so t to the 1, or 1 to the 4th. I can't get my mouth straight. T to the 4th, 1 to the 4th is 1 over 4. And that looks like x to the 8th over 4 minus 1/4. So there's my big F of t, right? Now, F prime of x. Let's see. Am I going to get my answer? Let's see. 8x to the 7th over 4, that doesn't look good, minus 0 is 2x to the 7th. It's not what I was expecting. And you notice that it's not equal to x cubed. Now, the reason is because there was another secret I didn't tell you about. Go back to the top. The real substitution of x, since that was just a plain x, it was just plugging in an x into the t's. It really was. But there was another trick. It was also that if this is t dt, the derivative of t, and I'm plugging in the x, I also need to have the derivative of x. In this case, with respect to 1, was a 1. So it was just simply substituting, but I also had to multiply that substitution by the derivative of the x that I plugged in. Since I was only multiplying by a 1, it didn't make a difference. Same thing over here. It was simply just taking an x and plugging it in, but then dt changed to not of a t, but of the x. And then the derivative of x was 1, so the final answer was cosine of x times the derivative of x with respect to x, and that still gives me cosine of x times the 1, which is cosine of x. See what happened down here? The trick didn't work because, sure, I plugged in the x squared. I'm plugging in an x squared into this t. So when you think about x squared plugging into this t, that turns into x squared to the cube. And then, instead of dt, which is what I had here, I have the derivative of x squared. The derivative of x squared with respect to x, and that gives me my x squared cubed, which is x to the 6th, times 2x, which is 2x to the 7th, which is the answer we got. So that's really the secret if you don't want to do all your work. But this is the secret. This is the blood and sweat and tears hard work. And that's why that didn't work. Okay. So I'm going to predict my answer for this problem. We had the trick that if I was integrating from 1 to x squared of 6 times t to the 1/2 dt, the trick was all of my x squared goes here. That would give me a 6 times an x squared to the 1/2 times the derivative of x squared, which is 2x. So if I'm lucky, that gives me a 6 times x times 2x, or a 12x squared. Let's see what happens. Big F of x is the integral from 1 to x squared of 6t to the 1/2 dt. That is 6t to the 3/2. That's adding 1 to a half divided by 3/2 from 1 to x squared. which that 2 times 6 is 12, and 12 over 3 is 4. So it's 4t to the 3/2 from 1 to x squared equals to, plug in the top first. So that gives me a 4x squared raised to the 3/2 minus, minus, plug in the 1. Square root of 1 is 1. Cubit is 1. It's 4 times 1 is 4. Minus 4. That simplifies to 4. X to the 6/2 is x cubed. Still minus the 4. Okay. F prime of x, the derivative of big F of x, should be 12 x squared plus 0. Drum roll. 12x squared plus 0. This is called the second fundamental theorem of calculus. Kind of cool, isn't it? Sure it is. So the shortcut that I already taught you, here's how we're going to write it. Got to collect my thoughts here. I think I can say something. If big F of x equals the integral from some constant, and it doesn't matter what constant, to some function of x. Could be an x, could be an x squared, could be a 3x squared minus 5x plus 1, could be anything. Of some function of, well, we were dealing with another variable, t dt. Then the shortcut for f prime of x using the second fundamental theorem of calculus will be, how am I going to do this? F of f of x f of x. Might be a better way of writing that, but I want you to realize that this is being plugged into here, times f prime of x. Probably should have done it better than that. Let me write it with two separate. The two f's are kind of in my way. Let me just do it nicer. I think you get the point, but let me call the top one. Let me not call it F. Let me call it G. That way, what I can say is it's. I can erase this inside here too, and whoop, that's not erasing. On any day now, and I can erase this too. May as well. What the heck? It's going to be f of g of x. That way you get your composite functions that we've had before, times g prime of x. I like this better. This looks better. This looks a lot better. Okay, now he starts out saying, do this the old way, find f prime the old way, then find it by using the theorem that I just listed up here. That's this theorem right here. I might be bored to do it more than once, but anyway, let me do it. Big F of x will be the integral. So I got to integrate this. So that's 4t squared over 2 minus t cubed from 1 to x, which is, that's the 2. This 4 and the 2 is a 2. 2x squared minus x cubed minus, plug in the 1. I hope you see that just gives me a 4 times 1 divided by 2, which is a 2, minus a 1. So 2x squared minus x cubed minus a 2 minus a 1 is a 1 minus a 1. And f prime of x will be 4x minus 3x squared. That's if I didn't do anything wrong, which, knock on wood. The shortcut says right away f prime of x should be, plug this function into this function. 4x minus x squared. Take this times the derivative of the top function, and so 4x minus x squared. And I'm wrong. Oh, what happened? Did I do wrong? Got the 4x part right. Oh, maybe I see why. Maybe I do. Did I integrate that wrong? T cubed over 3. Forgot the over 3. There it is. Over. So that becomes over the 3, over the 3. And that's 4x minus x squared. Okay. I told you, if I get it right. Do it an old-fashioned way. I think we did one just like this. Big F of x will be the integral from 1 to x of cosine of t dt. That equals the sine of sine of t from 1 to x, which equals sine of x minus sine of 1. F prime of x would be the cosine of x, and the derivative of sine of 1 is still 0. The shortcut way. The shortcut to getting to the derivative of the integral would be that function superimposed into there, cosine of x times the derivative of x, which is 1. That wasn't very exciting. All right, let's do another one. Big F of x would be the integral from 1 x squared. Wait a minute, these are the same ones we just did. These are the same problems we did. Okay, I get it. He wants us to prove. We could have gone over and looked at our answer. Is that what he said to do up here? Yeah, not only was it the same problem, the same method, but the same problem. So I already did these with that new method, remember? That f prime of x would be x squared to the third times 2x. X squared to the third times 2x. And then I already did this one too, so I'll move it on. Now, what if there's a negative 2 here? Don't be alarmed. Let's do it the old way and see what happens. F of x will be, oh, wait a minute. I know what he did this for you, because you haven't learned to take the antiderivative of this by itself yet. Okay, so you have to do the shortcut. And let it suffice to say that when you plug in a constant to whatever happened, that last term was always a constant because of this term being plugged into this function. Just picture it. You're plugging in a negative 2 in here. The negative 2 squared becomes a 4, and 2 minus 4, well, it's not looking very good at this point. But if I apply my trick that the answer should be the square root of 2 minus 2x all squared times 2 should be the answer. I mean, that should be using the theorem because it didn't matter what this bottom one is. So that equals to a 2 square root of 2 minus 4x. Now, obviously, there is an issue with the domain of this function. Right off the bat, you know that x can't be anything bigger than a half. X can't be anything bigger than a half. So I have some problems with this one. I'm curious what the author did on it. This problem here, okay. The problem is this function has to be on top. So you have to rewrite this before you can do anything. The constant has to be at the bottom. So when you change your limits around, remember that meant you did the opposite of the integral. Not a big deal. Here's another one you could not have done the old-fashioned way because you don't know how to find the integral of e to the cosine of t. Sorry, you just don't know yet. So what we do here is, using the second fundamental theorem of calculus, t becomes x squared. So it's e cosine of x squared with a negative out front times the derivative of x squared, which is 2x. Negative 2x e to the cosine of x squared would be the derivative. Okay, constants at the bottom, that's fine. H prime of x, all of cosine goes in place of t. Cosine of x all squared times the derivative of the upper limit function, negative sine of x. Doesn't really matter how you write it. Sine of x, cosine of squared x. Wow, fun. Pictured to the right is a graph of g, and the function f of x is this function. It's an integral. So, not sure how I'm going to apply that graph. Let's see. Find the value of f of 0. That means I'm using this function. F of 0 must be the integral from negative 4 to 0 of g of t dt. And I do believe he said that this picture is g of t. That is g of t. Okay, well that's not very exciting. I need the area bounded by the x-axis and the curve from negative 4 to 0. Negative 4 starts here, 0 ends here. Bounded by the x-axis means all of this area and all of this area. This is negative area, this is positive area. There is a very good chance that these two triangles cancel each other out. Let me just do a fast inspection. The area of this triangle, base is 2, height is 1, 2 times 1 is 2. Half of that is a 1. That's a negative 1 area. This one here, why did I say 2? It was a negative 3 to 4. You know why I can't see my can't see the, it went to, it was on 1. Okay, let me do it again. Instead of writing on top of it. Okay, try it again. 1 times 1 is 1. Half of 1 is a half. Negative half. Okay. This one, 1 times 1. Yeah, that's a positive half. So basically, these two cancel out. Next picture part, rectangle, and a quarter circle. So I'm going to go ahead and put, just for fun, I'm going to put negative half plus a half plus my rectangle. 2 times 1 is 2. Plus 1/4 of a circle. Because that distance here is 2. And 1, 2, 3, that distance is 2. So these are radii. So 1/4 of that circle with a radius of 2. 1/4 of pi times 2 squared. That canceled. That's 2 plus, well, that cancels 2 plus pi if all things are correct. Find the value of f of 2. Now, f of 2. I have the luxury of being able to erase everything I've done. F of 2 means the area. Well, I haven't, better write it out. Let's see, f of 2 is the integral from negative 4 to 4 of g of t dt. Negative 4 to 4. This is symmetric. It's an even function. It's symmetric on the y-axis. So this area that I had just found over here is identical to this area over here. So I can honestly say it's just double my last answer. So I think I'm going to go with equals to 4 plus 2 pi. Unless somebody finds something wrong, which never wouldn't surprise me. All right, he's changing the pace. Find f prime of 1. Remember what f is. F of x is the integral from negative 4 to 2x of g of t dt. F prime of x, let me write that out first, would be that secret shortcut, would be g of 2x times the derivative of the upper limit times 2. F prime of 1 would be g of 2, because 2 times 1 times 2. G of 2, this is a picture of g. G of 2 would be that value right here, a 1. So that would be 1 times 2, or 2. Okay, number 3 or 4. All right, f prime of negative 2. Remember what f of x is? F of x is the integral from negative 4 to 2x of g of t dt. So f prime, using the shortcut, would be g of 2x times 2 again. Same as the last problem we just did. Problem is x now changes. F prime at -2 would be g of a -4 times 2. So I go look at g at a -4. It's this point right here, a -1. -1 times 2, -2. Find the second derivative at 2. Well, let's start out with what we know. We know f of x is the integral from -4 to 2x times g of t dt. We know this is the shortcut version of g of 2x times 2. That's the derivative of 2x. Okay? So I'll just call it 2g of 2x. F prime, that was f prime. F double prime would be 2 of x, 2 times g prime of 2x. Don't forget the chain rule times 2. In other words, 4g prime of 2x. Now I need to do f double prime at 2, which is 4 times g prime of 4. 2 times 2. Well, we didn't do any g primes. Where am I going to get g prime from? Well, that's simple. Go to 4. And I wish we weren't at 4 because it's the end point. I'm not comfortable here. What's the derivative here? Well, I'm assuming it's part of this function, if it was a closed function. What's the derivative of that line? Well, the slope, let me do some erasing here so I can make a little more instructive. I'm going to double check it, make sure it's supposed to be a 4, though. Let me see. Oh wait, I'm doing the wrong problem. I was doing 3. I did 3. What am I doing? Did I lose my work? I lost some work here. There it all is. How did I get down here? I moved the paper. I moved it. Oh, I lost it all. Why is it moving on me? Wow. I know what happened, but I already did that one. Okay, I'm over here. All right. I have double prime of 2. We double check that I did the work right. F prime of 2 from -4 to 2x of g of t dt is g of 2x times 2, which is 2g of 2x. F double prime would be keep the 2, do the derivative of g prime of 2x times the derivative of 2 is 4, g prime of 2x. I'm plugging in the 2 into the x. Yeah, 4. G prime of 4. Okay. I'm just not comfortable with doing an endpoint, but here goes. I'm just going to have to assume it's the same as that line. And that slope looks to me like rise over run from -1 to 1. That's a 2. And from 2 to 2, it's a slope of a -1. So that's what I'll run with. F double prime of 2, 4 times a -1, which is -4. I'll look up the instructors and see if I was off my rocker. Another graph. On this, right, is graph 3 segments, semicircle. Okay, so what is this a function of? It doesn't say. Oh, this is all f. This is all f. F of t. But then he said, in addition, you have g. G of x is the integral from -1 to x of f of t of this. Okay, so to get g, you have to use the integral from what, -1 to x. This will be fun. Find g of -6. Well, g -6 must be the integral from -1 to -6 of f of t dt. Now, first thing I notice before I even get going on this, my upper limit is smaller than my bottom limit. So we should use that property to put them in the right order. We always want to go left to right. So we're going to write negative of the integral -6 to negative. Wait, why did I write 6? Scratch everything I just said. I was watching my cat. Silly me. Can't get distracted on your kitty cats. They'll steer you wrong every single time. Okay, it was -1 to x, not 6 of f of t. Okay, there's nothing wrong with that. And, well, no, this is not, oh, wait a minute, it was. Hello, this was g of x was this. I was right. Sorry, kitty cat, I was blaming you. G of -6 is the integral from -1 to -6 of f of t dt. This, I do have to switch it around. G of a -6 equals to the negative of a -6 to a -1 of f of t dt. And so what is the negative of the integral of f of t? That's area from f from -6 to -1. Here's -6. Here's -1. The area bounded from here and here. Positive area, negative area. So let's get to work. I don't have to even, and then I'm going to do the opposite of that area. So let's see, what's the area of this triangle? 2, 1, 2, 3, 4. 2 times 4 is 8. Half of 8 is 4. This area is positive 4. This area here is a trapezoid. One base is 2, the other base is 3. Together that's 5. So you add the bases, multiply by the height, which is 2. 5 times 2 is 10. Take half of that, 5. This is a negative 5. So I'm positive 4 minus 5. Let me do this math again. 3 plus 2 is 5. Times 2 is 10. Half of that is, yes, I think I'm okay. So the answer is 4 minus 5 is a negative 1, with a minus is 1. Using, interesting. I didn't have a function for f, so I couldn't do a shortcut. I didn't have a function for f. I have line segments. So I have to use the concept of what does the integral mean. G of 6. Oh. Yeah, I just did g of negative 6. Now I'm doing g of 6. So g of 6 would be the integral from negative 1 to 6 f of t dt. And this one I don't have to switch because the limits are in the right order. So all I have to do is the area of f bounded from negative 1 to 6. Negative 1 to 6. Here's negative 1. And here is 6. What do I have? I have a trapezoid. Negative answer. That's going to be negative. And a quarter circle, which is positive. Let's do the trapezoid right here, just because I'm right here. 1, 2, 3, 4, 5. 1, 2. 1, 2, 3. 5 plus 3 is 8. 8 times 2 is 16. Half of 16 is 8. That's a negative 8. Quarter circle. Radius is 2. Radius is 2. That's how I know it's a quarter circle. That quarter circle will be pi r squared over 4. And that's 2 and 2, so it's pi. Positive pi. Negative 8. Negative 8 plus pi is negative 8 plus pi, or pi minus 8. Okay, now g prime. Now we're talking. Now we are talking. If g of x is equal to negative 1 to x of f of t dt, then g prime of x, using the second fundamental theorem, will be f, plug this in, of x times the derivative of x, which is 1. Do I have it right? Yeah, nothing fancy. Nothing fancy. So g prime at 6 is equal to f of 6. Where's f of 6? Glad you asked. F of 6, let me erase all my gobbledygook. F of 6. This is my picture of f, all right. So f of 6 is right here. It's a 2. 2. G prime of 2. Let's not do all the work again. We already know that G prime of x was equal to the same thing as it is over here, f of x times 1. So G prime of 2 just means what is f of 2? Go up here. F of 2 is right here, negative 2. So that's not too bad. G double prime of 2. Well, we already know that G prime of x was equal to f of x. That must mean G double prime of x must be f prime of x. G double prime of 2 must be f prime of 2. Where was 2 at again? 2 was right here. And he's asking me, what is the slope here? Now, guess what? For sure, I'm not going to call it, because that's a sharp turn. I'm going to make an executive decision and say undefined. G double prime of a negative 4. Well, I'm not going to do all the work again. I already know that G double prime of x is equal to f prime of x. G double prime of a negative 4 would be f prime of a negative 4. Go back up and look at my function at a negative 4. Right here. What's the slope of that line? Rise over run. 1, 2, 3, 4, 5, 6. 1, 2, 3. Negative 6 over 3, negative 2. Page. It is. It's the last page before you do day 61 of homework. And there are your exercises. They're already on in your Google Classroom. So, got till tomorrow night. I wish it was tomorrow night. That way we got to get this stuff done, but I don't want to kill you. Unless you all tell me. If all you STC students tell me, hey, lecture every day to get everything done, I'll do it. And then we'll be done. It's faster. It's more important for the STC. And non-STC, you're going to get a lot of privileges just for being here. Okay? But STC, they're not as forgiving. So, hit me up with any questions, please. And I'm going to call it. And then I'm going to go be chilling like a felon. I'm sure I said it wrong.